My name is Stein. I'm a front-end developer at Kununu. And today I'm going to talk about what we're doing for our page speed in our JavaScript applications. First, a short introduction in case anybody here doesn't know what Kununu does. We're a company where people can rate their employers. So they can give reviews about categories like how is my salary, how is my working conditions, stuff like that. And our goal is to give transparency to the workplace. But that's not what I'm talking about today. 2 years ago, we basically came up with a new front-end architecture. Our old architecture became a little bit long in the tooth. It was using jQuery and Angular. And we decided we're going to use something more modern. So what we decided on was to build all our following applications using React. And we also wanted to use Express servers, so Node.js servers, to handle all our requests and responses. And we also decided to use server-side rendering. That was a requirement by our SEO team, but it is also the first step that we took for having good performance in our applications. In case anybody here doesn't know what server-side rendering is, you're basically using your Node server to parse the React application. So instead of presenting to the user an empty page where he then has to download a bundle, you already give him a full HTML response. But that doesn't mean that he doesn't need the bundle anymore. He still needs to download this because this is used then for interactive stuff, so like form validation or animations, asynchronous data, yeah, all these kinds of things. But it greatly improves the first render you get on the page. And that's also really important for Google because they crawl your page much more often when you have a good HTML response for them already. We also agreed on a performance testing strategy. So we're using Lighthouse. And Lighthouse is a tool that was bought by Google a few years ago. And it's built into the Chrome browser itself nowadays. So if you open up your web developer tools, you have this little tab. It's called Audits. And there you can just make one of these Lighthouse tests. And Lighthouse is trying to then network throttle and giving you a mobile view of your page. So it basically tries to emulate what would a user see in the real world on a mobile device when he has 3G speeds. We also have pretty clear goals for our performance. So we want to have a first meaningful paint after 1.5 seconds. So that's the first time that the user would see something on his device and he can start reading stuff. And after 5 seconds, the whole page should be completely interactive. So then every form that he fills out should be validated. All asynchronous data that is needed should be there. Yeah. Throughout 2017, we started rolling out our new features. We rewrote the reviews page, which is the most important page on our website, because that's where we get the data from all our users. And we also decided to rewrite the homepage. It got a new design with a more modular, component-based structure. And we also introduced one new feature, the question and answers feature, where users can ask questions to specific companies. And then people from this company, so the employer himself or maybe other people that work at this company can go back and answer those questions to improve the transparency. And you will probably hear me noticing this feature a few more times because that is the feature that I work on most of the time. So yeah, when we introduced the new architecture, we were pretty sure performance will just come by itself. It won't be an issue because we're using this new awesome framework. We're using server-side rendering, so all the stuff is already done on our side. Of course, we were completely wrong about this. This was a Lighthouse test I did 1.5 years ago after we launched our new features. And you see that it's nowhere even close to the goals we decided on in the beginning. Our full page load took 17 seconds, which was just awful. And the first time the user would see something marginally resembling the content he had in the end was after 12.5 seconds. So that's 11 seconds slower than what we wanted to have in the beginning. Fortunately, Lighthouse also made it easy to identify some culprits in that regard. So we immediately noticed we had a lot of blocking scripts, so JavaScript files or CSS files that were keeping the browser from rendering HTML because they blocked the render. We also back then had a fairly large bundle. It was slowly approaching 2 megabytes, which was just too much. Our DOM structure was very convoluted. I mean, you probably know this. We're all lazy developers, and so sometimes you just add empty component containers, and they have div elements, and you actually don't need them, but you still have them. And also, we didn't think too much about our resource caching strategy, so how we should serve assets like images or even the bundles themselves in a good way. And the rest of this talk will be now 7 steps that we took in the last year to improve our performance. And let me just start by saying none of these are specific to React. They're fairly framework agnostic, and you can use them in any framework you want, even with PHP code or Java code. Step 1 was using asynchronous CSS. I already said this, so we had lots of blocking scripts, so render blocking scripts. And fortunately for JavaScript, it was a fairly easy problem to solve because all modern browsers, they have these attributes called async and defer. And you just put them on your script tags, and then you basically tell the browser, this is a JavaScript file I need, so download it as fast as possible, but don't let it keep you from rendering anything. So it happens asynchronously. But unfortunately for CSS, something like that doesn't exist. But there are good approaches for that out there. So we're using something called Load CSS. It was invented by the Filament group, which some of you might know. And the basic idea behind this is that you identify what is the most important CSS that you have. That would be everything that the user sees before he starts scrolling on the page. And you put this actually into the head tag of your website. And the rest of the CSS, you load that part asynchronously via JavaScript. And this requires less than 10 lines of JavaScript code, and it works in all modern browsers. And so what you then get is basically that the user sees something on his screen already while the browser is downloading CSS in the background. And there might be some flashing going on, but it's a much better experience because the user can already start reading stuff. And if you think to yourself now, okay, this sounds very tedious because identifying all your important CSS, I don't want to do this. We're of course automating this. So we're using a tool called Penthouse. It's an NPM library, and it uses a headless Chrome that just parses the site and gives you this critical CSS that you need to put into your head. And on the next slide, I show you a video comparing these two approaches. And so on the right side, you have the one with the asynchronous CSS approach. And you should immediately see that it gives you something much faster on the screen than the classical approach. I recorded these two examples with slow 3G speeds, and both take roughly the same time to have a complete render. But the one with Load CSS shows content to the user already after half the time that it takes the other approach to display something.
How much is your total CSS load?
So for the head part, it's right now roughly 10 kilobytes. And the rest is, I think, 20 kilobyte gzip. So I don't know how much it is in total then. The second step we took was splitting up our applications in a better way. As I said already, we had a fairly large bundle at the time, and we had to come up with a solution for that. And so we did something very drastic. We actually just said, okay, instead of having one monolithic React application, let's just split it up at logical steps. So now we have 3 small applications, one for the reviews page, one for statical pages like the home page, and the third one for profile-specific pages like question and answers. And by doing that, we were able to quickly reduce the amount of code that was in the main bundles for each page, because before it used to be that the user had to download all the code for all the pages and all the third-party libraries for all the pages. And the second step that we did in the last few months was actually starting to use bundle splitting. That wasn't possible for us a few months ago, but with newer frameworks that we're using right now, it's made easier. If you don't know what bundle splitting is, you're basically using functions that Webpack give you to import bundles asynchronously. So you again define some logical steps. So for example, here that would be this report misuse modal that most people probably will never see. And only if the user clicks on the button, he loads a separate bundle that displays this content. And by using this and utilizing this, you're able to, again, reduce the amount of code you have in your main bundles because you split it up into several smaller chunks. The third step we took was reevaluating our Webfont strategy. Of course, back then we had a pretty nice, pretty modern web font. It's called Whitney, you all see it here. And it came in 3 styles. It had a bold font, it had a regular font, and an italic font. And it looked pretty nice, it was very readable, but it came with 2 major downsides. The first one was, of course, that it was fairly expensive. It was a subscription service that we had to pay every month. But for me as a front-end developer, the more important part was that it was one of the biggest assets we actually served to the user. It was 250 kilobytes that just were needed for this font to display. And so then we actually went to our designers and said, hey, can we take a different approach? And what we came up with was using system fonts. So these are fonts that you already have installed on your devices. They are specific to each device you have. So on macOS, you get San Francisco. On Android devices, you get Roboto. But they are all pretty readable and highly optimized for high-resolution screens and low-resolution screens. So they are very readable and have a very nice typography. And also, they give you this nice side effect that your websites look almost like native applications because they look the same as other applications that you're using on your device. Also, what was fairly awesome about this step was that it was pretty easy to do the same change in the old architecture. As you can imagine, we still have a lot of pages that are not updated to our modern architecture, but even there it was very easy to say, okay, don't serve this font anymore, use system fonts. We optimized a little bit our style sheets, and that was it basically. Step 4 was reducing our external dependencies. Since we're using Webpack to build our main bundle, there are really cool tools out there like this Webpack bundle analyzer that clearly displays to you what are the biggest chunks that you have in your bundle. And oftentimes, especially in the beginning, we noticed it was third-party libraries that we were using. And my prime example for this is something that I introduced myself. It's Redux Form. And it was a pretty nice library that gave you form validation basically for free. But at the time, I didn't think about that this would also be a really huge dependency that we suddenly introduced to our bundle. And when we saw this and re-evaluated our approach, we said to ourselves, okay, form validation is not rocket science. We can do this ourselves and save lots and lots of code by doing it ourselves. And of course, we did this with lots of other libraries as well. And yeah, so that's something that everyone here can probably do. And related to that was also updating our packages on a regular basis. A really cool example for this is React 16. When we started writing our applications, React 15 was still the current version. But when the newer version was released, Facebook even on their blog advertised that one of their main goals was reducing the amount of code you load with this library. So just by updating to React 16, we were able to save over 50 kilobytes un-gzipped. And with that also came faster rendering. React 16 actually took some steps to improve the rendering of each and every one of your components on the page. And I don't say that this would happen every time you update a library, an external library, but most developers out there also care about similar things. So if you trust good libraries, they also will probably take some steps to reduce your file sizes. Step 6 was refactoring our templates. So I said this already in the beginning. We had fairly convoluted DOM structures in some places. And Lighthouse gives you this very clear goal that you should aim to have less than 1,500 DOM elements on the page. You can probably imagine that if you have lots and lots of elements on the page, it takes the browser some time to render those and also to calculate styling for this. And so if you have components like this where you have empty div containers, try to reduce them as much as possible. So I introduced them back then because I added scrolling components or animation components. But actually, when I re-evaluated this, I saw that it's actually not needed, and I can come out with cleaner code in the end. And you might now think to yourself, okay, but 1 or 2 empty div containers, that's, yeah, I don't care about that. But if you multiply it by the amount of components you reuse, and this just gets out of hand pretty quickly. And an even more drastic approach we took there on the Q&A page was, okay, I just see that this image doesn't render very nice on this screen, but it was adding pagination to our pages. When we introduced the features, users would always load all the question and answers that have ever been asked for a specific company. And we quickly realized that this was not a very scalable approach. Our APIs were slowing down, our rendering was slowing down, both on the server and both on the client. And so a few months ago, we went back and actually said, okay, we just limit the amounts of questions we load in the beginning to 30. And that way, we have much faster rendering times for these pages. Step 7 was utilizing CDNs in a better way. So we were already using AWS, but we had lots of assets like our logo or country flags that were used in our language switcher. And these assets were actually baked into our code because we were using SVGs and they were just inlined into the HTML. And with that came two problems. On the one hand, we couldn't reuse these assets across the applications. So even though the user already downloaded the logo on one page, he would have to download it on the next page because it was simply part of the bundle. And also, these assets were not cached in a good way because every time we did a new deploy, these caches would be invalidated and the users had to re-download these assets. And what we're doing now is actually pretty simple. We manually uploaded these assets to S3 and linked to them in our applications. And the second thing we did with AWS was actually starting serving our bundles from Amazon. With every deploy we're doing now, we have an extra step that just uploads the style sheets and JavaScript files to AWS, and that actually reduces the amount of work our Node.js servers have to do greatly, because before every Node.js server had to both render HTML responses but also serve JavaScript files and CSS files. And now by using AWS, this is just less amount of work to do. Yeah, as I said, we took 7 steps roughly. There's of course a lot of smaller optimizations as well. But you might now wonder, okay, where are we now with page speed? And I'm pleased to say that we're at a much better place than in the beginning. Our time to interactive could still be a little bit better. It's just over 5 seconds, so just over the goal that we have. And our first contentful paint is right where it should be. And of course, it was a lot of work to do, but nothing of that was so complex that it ever scared us to do. And I hope all of you can reuse some of the stuff I showed here. So yeah, thank you for your attention. And